Here we start the second session of two-dimensional random variables. In the last class, we discussed two-dimensional random variable, its definition and probability distribution function, distribution functions, and discrete and continuous random variables, etc. Also, we discussed the properties of two-dimensional random variables. Okay, now in this session, we do some problems of two-dimensional random variables. Okay, so this is the first question. So here we are given the question, let xy be the continuous random variable with joint PDF given by f of xy equal to e raised to minus of x plus y, x lies in between 0 to infinity, y lies in between 0 to infinity and 0 otherwise. Here we have to find the distribution function capital F of xy. Okay, distribution function of xy. So, in the last class, we discussed the equation for distribution function. So, whatever be the random, two-dimensional random variable, we define the general definition for distribution function is f of xy equal to probability of x less than or equal to x, y less than or equal to y. And here we are given the random variable is a continuous random variable. In the case of continuous random variable, how will you find the distribution function? To find the distribution function, we have to take the integration. So the equation for distribution function is integral. We have to take the double integral. Since there are two variables, we have to take the double integral and it is given by integral u equal to minus infinity to x integral v equal to minus infinity to y f of uv dv du. So f of uv, what do you mean by f of uv? We are given the function f of xy. In the last slide we have seen that f of xy equal to e raised to minus of x plus y and therefore f of uv equal to e raised to minus of u plus v. This is given here. E raised to f of uv is e raised to minus of u plus v. And what are the limit of x and y given? We are given x is greater than 0 and y is greater than 0. So when we take the integration is from minus infinity to x, but x varies only x greater than 0. So how will you take the limit of u? U will be 0 to infinity, 0 to x. Similarly, since y is greater than 0, we can take v equal to 0 to y. So instead of the variable u, x and y, we write here the variables as u and v. Okay. So how will you integrate double integration? You know to integrate double integrals. How will you integrate? So when we integrate double integrals, first we have to evaluate with respect to a particular variable, keeping other variable as constant. So here we can integrate first with respect to v. Then we have to keep u as constant. So first we separate e raised to minus u plus v into e raised to minus u into e raised to minus v. We know e raised to minus u plus v is same as e raised to minus u into e raised to minus v. So e raised to, first we are going to integrate with respect to v. So since we are integrating with respect to v, u is constant. So e raised to minus u will be constant. So we can take that outside the integral of v. So this is equal to, and you know, what is the integral e raised to minus v? Integral of e raised to minus v is e raised to minus v divided by minus 1. And we have to apply the limit from 0 to y. So after applying the limit, we get integral of e raised to minus v as 1 minus e raised to minus y. That is given here. 1 minus e raised to minus 1. Now we have to integrate with respect to u. When we integrate with respect to u, we have to take 1 minus e raised to minus y outside because that is independent of u. So integral of e raised to minus u, as in the case of integral e raised to minus v, integral of e raised to minus u is e raised to minus u divided by minus 1. And applying in the same manner, we get the integral value as 1 minus e raised to minus, that is given here 1 minus e raised to minus 6. So after integration, we get the distribution function f of xy equal to 1 minus e raised to minus x into 1 minus e raised to minus 1. Okay. So in general, how will you write the distribution function? After integration, we get the value. So when we write the distribution function, we have to write in a given interval. So f of xy equal to 1 minus e raised to minus x into e raised to minus y, x greater than 0, y greater than 0, because we are given the limit as limit of x and y as greater than 0 and 0 otherwise. In all other intervals, capital F of xy will be 0. So this is the distribution function of the given PDF. Okay, now we move on to the next question. So in this question we have to find the value of k, and we are given the distribution function f of xy, not distribution function, we are given the probability distribution function f of xy equal to k into 1 minus x into 1 minus y, 0 less than x, y less than 1. That is, limit of x and y are in the interval 0, 1. And we have to find the value of k. So we are given the joint PDF and we know the result that this is some properties of distribution function. We have the property that total probability will be 1. So in the case of continuous random variable, total probability we denote by integral x equal to minus infinity to plus infinity integral y equal to minus infinity plus infinity f of xy dx dy equal to 1. Okay, so we have to apply the limit of x and y. Here also we are using the double integral. So what are the limit of x and y? Both x and y have the same limit 0 to 1. So we write the double integral as integral 0 to 1 integral 0 to, that is x equal to 0 to 1, y equal to 0 to 1, and f of xy. What is f of xy? K into 1 minus x into 1 minus y dx dy equal to 1. See, then as in the case of last problem, how will integrate the double integrals? So to evaluate double integrals, we have to keep one variable as constant. Here we are integrating with respect to x first. So we can take k into 1 minus y, which is constant with respect to x. So we can take outside the integral of y. So that this integration become integral 0 to 1, k into 1 minus y, integral 0 to 1, 1 minus x, dx, dy equal to 1. Then now, after integration, we get apply integral of 1 minus x. We know what the integral of 1 minus x, we have x minus x square by 2. And when we apply the limit 0 to 1, we get 1 minus 1 by 2, which is equal to 1 by 2. So, in the next step, we are taken that 1 by 2 outside the integral. 1 by 2 taken outside the integral. This is the value after we get after evaluating in the integral with respect to x. So 1 by 2 into, and k is also constant. Now we have to integrate with respect to y. So similarly, integrating with respect to y, the integral value, integration is y minus y square by 2 within the limit 0 to 1. Again applying the limit, we get 1 minus 1 by 2, again 1 by 2, 1 by 2 into 1 by 2, 1 by 4, 1 by 4 into k. So that we get 1 by 4 into k equal to 1. So that what is the value of k? K equal to 4. So to find value of k, if we are given the PDF, just integrate with respect to x and y. That is, take the total probability and equate that to 1. So that we get the answer. Okay, so here we get k equal to 4. Now the next question is, the joint PDF of a bivariate random variable xy is given by f of xy equal to 4xy within the limit 0 less than x less than 1, 0 less than y less than 1 and 0 elsewhere. Here we have to find probability of x plus y less than 1. So in the case of bivariate random variable, to find the probability, first we have to draw the regions. How will you draw the region? To draw the regions, first of all, we have to take all the limits given. So what are the limits given for x? X lies in between 0 less than x less than 1. So using that limit, we have to draw the lines x equal to 0 and x equal to 1. And from the limit of y also, we have to draw the line y equal to 0 and y equal to 1. And what is the required probability? We have to find the probability of x plus y less than 1. So since we have to find the probability of x plus y less than 1, we have to draw the line of x plus y equal to 1 also. So here we have 5 lines, x equal to 0, x equal to 1, y equal to 0, y equal to 1, and the line x plus y less than 1. So how will you draw that figure? So here x equal to 0. What do you mean by x equal to 0? X equal to 0 is y-axis itself. And what is y equal to 0? Y equal to 0 is x-axis. Now we have to draw the line x equal to 1. So take the point x equal to 1 in the x-axis and draw a line parallel to y-axis. This is the line x equal to 1. And now this is the line x y equal to 1. And you know how to draw the line of x plus y equal to 1. So we get x plus y equal to 1. So this is the line x plus y equal to 1. Now we have to take the region, which is the required region. X lies in between 0 and 1. 0 less than x less than 1. So the limit of integration, when we take the limit of integration, the region of x should be in between x 0 less than x less than 1. That is, it should be between 0 and 1. And y, what is y? Y also should be less than 0 and 1. So here like this, y should be less than, y in between 0 and 1. Now we have one more line, x plus y less than 1. So we have to take all the points below the line x plus y equal to 1. So this is the line x plus y equal to 1. So x plus y less than 1 means this region. So satisfying all the condition, we get the required region of integration as this shaded portion. Okay, so this is the given figure. Now, how will you find probability? So, probability of x plus y less than 1 means we have to take the double integral over x and double integral over y, f of xy, dy dx or dx dy. This is the equation to find the probability. Okay, so we have to write the, now we have to write the limit of x and y. How will you draw the limit of x and y? So to draw the limit of x and y, the one variable, since it is a double integral, one variable should take constant limit and the second variable should take variable limit. Okay. How will you take that constant limit and variable limit? So in this problem, I have given constant limit to x. So what is the constant limit to x? X varies in between 0 and 1. So x limit of constant limit for x is 0 to 1. And to find the variable limit of y, how will you find the variable limit of y? To get variable limit for y, we have to draw a strip parallel to y-axis like this. Draw a strip parallel to y-axis. And to get the limit, you take the bottom portion of this strip. So the bottom portion of this strip is on the line y equal to 0. And the top portion of this strip is on the line x plus y equal to 1. So we have to take the value of y at the bottom and top portion of that strip. So the value of y at the bottom portion of the strip is y equal to 0 and the value of y on the top is y equal to 1 minus x. So the limit for y is from 0 to 1 minus x. So the variable limit for y equal to y is 0 to 1 minus. Instead of this variable limit for y and constant limit for x, we can interchange. But if you want, you can give constant limit for y and variable limit for x. That is also possible. Okay. So either give constant limit to x or variable limit to y or in reverse manner. Okay. Now moving to the problem. So here I have given variable limit for y and constant limit for x. So x varies from 0 to 1 and y varies from 0 to 1 minus x. And what is f of xy? F of xy equal to 4xy into dy dx. So as in the case of double integral, how will you evaluate double integrals? We have to keep one variable as constant and integrate with respect to the second variable. So here I am integrating with respect to y first, keeping x as constant. So what is the integral with respect to y? Integral 0 to 1 minus x and y dy. Okay, so that's integral is y square by 2 within the limit 0 to 1 minus x. Then applying the limit, we get 4x into 1 minus x whole square divided by 2 dx. Now expanding and simplifying the second term, we get the equation integral x varies from 0 to 1, 2 into x minus 2x square plus x cube with respect to dx. Now integrating with respect to x, we get 2 into x square by 2, 2 into x cube by 3 plus x raised to 4 by 4 within the limit 0 to 1. And applying the limit, we get 2 into 1 by 2 minus 2 by 3 plus 1 by 4, and simplify, we get the answer as 1 by 6. So in this session, we discuss three types of problem. One is finding the distribution function, and second one is if you are given the joint PDF, from that we have to find the value of k using the property that total probability equal to 1. Now third one is finding probability of bivariate random variables. Okay, hope you all understood this one. Thank you.